The Rajan water treatment plant is located near the heart of Queensland, near the Brisbane city in the Wapping Street. It is designed to meet the waste requirement for a total area of 2,250 hectares under the Redland City Council. The design population is 38,000, but the plant now handles the waste for about 41,000 people. The influent sewage has the water parameters of total nitrogen level of 70.7, total phosphorus of 11.8, and the BOD 270 and the COD 514. The plan was designed for 15 years and can be extended up to 20 years. The incoming water is basically rural, as the most of the area are rural areas, and the waste generated is basically domestic. The plant is designed to treat the water to the standards mentioned by the Environmental Protection Act of 1994. The treatment begins when the domestic sewage water reaches the screening chambers, then the grit removal, then the oxidation dish, and then to the clarifiers chlorination, then for dechlorination, and the treated water comes out. The process begins with the earthworks. This includes screening and grit removal. This is designed to deal with an average of 6 megaliters of water per day and is estimated to produce a solid waste of 400 to 500 kg of solids. If this larger solid particles makes it to the downstream process, it can seriously damage the downstream process and the equipments. The screen used in the Redland water-based system is about 5 mm, and brand screens are used and mechanically cleaned by rotating band. The screened waste materials include rags, big particles, and other bulky materials. This is how the process works. The in-pounds larger solid particles get sieved out by the screens, and the screens are periodically cleared out by rotary arms. This gradually pulls up the waste and carries them into waste disposal bins, from where they are sent to landfills. The screening process is followed by the grit removal process. The particles that makes it past the screen get trapped at this stage of the water treatment process. This includes small particles like the cones, small rocks, and other small stuff that ends up in the wastewater. This is done with the help of a rotary vortex chamber, where the pump rotates and causes the larger particles to settle down. Oxidation ditch is responsible for the biochemical nutrient removal. Substances such as carbon, phosphorus, and nitrogen are removed at this stage. The phosphorus is removed in the anaerobic zone, while the nitrogen is removed both in anaerobic and aerobic zone, and the carbonaceous compounds are removed throughout the aerobic zone. The activated sludge is returned back to the anaerobic zone to enhance the phosphorus removal process. The phosphorus is basically removed by phosphorus accumulating biomass. This biomass is then removed along a sludge with a long solid retention time. The bioreactor used here is a track reactor, basically due to its shape. The water moves at around 0.35 meter per second. The ditch volume is around 9.9 megaliters and it runs 24/7. The hydraulic retention time is usually 2 days and the solid retention time is maintained at 18 days. The DO level is usually maintained as 1 milligram per liter to enhance the biological growth. Liquid alum is used as the coagulation before The clarifiers. Liquid alum reacts with the suspended particles and turns them into particles of larger mass. These flocks are easier to separate. Clarifiers. The flocculated larger particles settle down inside the clarifiers by gravity. The speed of the water moving around inside this clarifier is around 1 meter per hour. The diameter of the clarifying tank used in the Rajan is about 32.5 meters and the volume is 2.6 megaliters. It generates both activated sludge and the clean water. The activated sludge is taken back into the bioreactor. This is how the clarifier works. The feed water from the bioreactor is pumped directly from the middle and up through energy dissipating inlets which ensure the reduction in the speed of the water. This allows the larger flocks to settle down faster. The settled flocks are removed by the raker arm and sent back as sludge. There is also a considerable growth of flocks on the top. This is skimmed out with the help of a skim removal mechanism arm. The pure water from the clarifiers is ready to be disinfected. The sludge from the clarifiers whereas go to the sludge dewatering process. The Rajan Bay uses the filter belt press to dewater the sludge, and the sludge is initially thickened and is poured onto belts. This filter belt removes most of the water as the sludge moves along it. The remaining water is squeezed out with the help of press made by multiple rollers. The water collected from the drying process is directly sent back to the oxidation ditch for further treatment. And the sludge comes out as sludge cakes, which are dry and ready to be sent to landfills. The belts are then washed off. The Rajan Bay produces about 15 tons of filter cakes daily. The treated water from the clarifier is then sent straight to the chlorination tank. Chlorine is added such that there is like 0.01 milligrams per every liter. The chlorine basically kills all the pathogenic organisms that are present in the water. the water after the chlorination is ready to be sent out. However, even after the chlorine disinfection, the water is not fit for human consumption but can be used for irrigation and other domestic purposes. The Qin sewage treatment plant is managed by a control system which uses a SCADA program to control the working of the sewage treatment plant. The plant is thoroughly monitored by this software, and any warning or any change in the running process is notified instantaneously. It can be used to adjust the chlorine concentration, the amount of effluent present, and the dissolved oxygen level. This ensures that there is optimal conditions for the bacteria to grow and thrive in the digester as well. They also take in daily reports and readings of all the primary data. This is from where the sewage treatment plant is smoothly run and controlled and maintained. Now we have come across a series of processes such as the screening, the grit removal, the oxidation ditch where the bacteria eats up the organic compounds and such materials such as nitrogen, phosphorus, and then the clarifiers and the sludge from the clarifiers are sent to the sludge dewatering process, and it's then sent to the landfills. The clear water from the clarifiers are sent directly into the chlorination chamber where it gets disinfected. And the water coming out after the disinfection meets all the standards put up by the Queensland government.
Disinfection is the final water treatment process, and the water coming out is safely disposed to the environment as it does not contain any harmful substances that are threat to the environment.
After the entire treatment process, 70% of the treated water is disposed as it is into the Hilliard spray, and the rest 30% is disposed into the lagoons for the spray irrigation of about 68 hectares of irrigation land.
The wastewater scarcity is one of the most important problems that planet Earth and humanity faces at the moment. The availability of fresh water that's fit for consumption or for any other domestic use is running low and low every day. The installment and the running of the water treatment plants across various cities and towns is in a way reducing the load on the environment as it puts back fresh water back into the environment. And the Rutland Water Bay, they are doing their part to save the water out there. Now the question is that, are you willing to do yours?